The next thing I want to talk about, this is where things start getting a little interesting. Now I'm going to talk about service persistence. So, systemd is the service manager that is commonly used in Linux to manage services. And many of the services that you're running are probably managed by systemd. So, for example, when you started your Apache service, right, you said sudo system control start Apache 2. The system control helps you manage your systemd services. Each of those systemd services has a file that's associated with that service. So if I said sudo system control list unit files, and I searched for Apache 2, you'll notice that Apache 2 has two service files that are associated with that service. Where are those files located, you may ask? Well, it depends on the service, but there are a couple common directories where these files are located. The first one is etc systemd. That's one place. A lot of the times they're in the system folder or in the user folder. The other place where you can find them, and especially if the service was installed as a package, a lot of the times it'll put the service file in /lib/systemd. And again, if I look in this directory, there's a lot more stuff to look at. We also have this user, and we have system up here, and that's where you can find more service files. These are not the only places where they're potentially located. There are many different places where you can find service files in Linux. For example, the one for Apache is in lib systemd system. And if I print out apache2.service, you'll notice we have that apache2.service file here. Taking a look at that file, what kinds of information does it contain? Well, one of the pieces of information that it contains, and probably the most important one, is exec start, which defines what actually gets run when we start that service. So when I say systemctl start Apache 2, the command that it's actually going to run is this one right here. So, as attackers, what can we do with this information? Well, we can create our own backdoor service. And we could even set that service to run on boot. What does that mean? Well, if the target reboots their machine, we can pretty much run any command or set of commands we want as long as that service is set to run on boot. So, we could run a command that will disable firewalls when the target reboots their machine. We could run a command that causes the target to connect back to us, the attacker, and so we maintain access to them even if they reboot their machine. So, in order to demonstrate this, I'm actually going to upload that payload that I generated from Sliver, and that payload caused the target to connect back to me. I'm going to create my own systemd service. I'm going to set it to run on boot so that it starts automatically. And then I'm going to set this exec start to be my malicious payload that causes the target to connect back to me. And what that's going to do is if the target ever reboots, it doesn't matter that I lose access, because as soon as they reboot, the target will connect right back to me and I'll have my access back again. So, in order to demonstrate this, I'm just going to make a copy of this apache2.service. I'm going to say sudo. So for this one, again, you need to be root. So I'm going to assume that as the attacker, I was able to get in and get root. So what I'm going to do is I'm going to copy Apache 2 and just work with that one. I'm actually going to save it in etc systemd system, and I'm just going to call it backdoor.service. Then I'm going to edit that. I'm going to remove everything that I don't need. I can actually set the description to something like backdoor. I don't need that. Don't need that or any of that. For the service type, I'll set it to simple. And for the exec start, this is where I'm going to put the path to my malicious payload. But in order to put the path to my malicious payload there, I actually need to upload my payload. The payload's currently sitting on my Kali machine. So I'm going to host it over HTTP from my Kali machine. And then I'm going to download it onto the target. And I'm going to save it to some place where it's kind of inconspicuous, like, for example, bin. And we'll use wget. And we'll grab it from my attacking machine on port 8000. And what I want to grab is the payload. Then I have to make it executable. Taking a look at that payload file, it looks like root owns it. It's executable, so that looks good. And now if I go back to editing that backdoor that I created, that backdoor service, I just have to specify the full path to my payload. So I'll do that right here. Save that. And because I made a change to a service file, I actually have to reload the systemd daemon. And I can do that with system control daemon reload. And then from there, I'm going to set the service to run on boot by saying system control enable backdoor. And then just for the sake of demonstrating or making sure that it works, I'm going to run it right now. So I'll say system control start backdoor. And if all goes well, we should see a connection back to our attacking machine via sliver, right? So here I got this new beacon. I can actually interact with it. So if I say use and the name of the beacon, a beacon is basically like a interactive session that uses that command and control process that we talked about before. So from here, I can actually like list files, for example. I can see who I am. I can print my current working directory. And so looks like we have pretty much full control here. But now here's the thing. Let's say the target decides to reboot their machine. So let's say I did reboot, just like that. Now we lost our access. And if I try to issue commands here, you'll notice I'm not going to get any output back. It's just going to try to task it, but it's not actually going to get anywhere. You'll notice if I look at my active connections here, that this connection is no longer active, which is indicated by the red. But pretty soon, when the system reboots, I'm actually going to receive a connection back again because that service is going to run. It's going to run that malicious payload, and it's going to connect back to me, the attacker. So I'm going to fast forward in the video till when that happens. And I fast forwarded a little bit. It actually looked like it connected back to me twice for whatever reason, but it looks like one of those sessions remains active, so that's fine. And that's this one. And I can interact with it again. I shouldn't say sessions. Sessions are a different thing in Sliver. One of these beacons is active, or one of these connections is active. And if I try to list out files, again, hopefully now it should work. So even though the target rebooted and we lost our initial access, it doesn't matter because through this service persistence, we were able to keep our access. So as defenders, how do we counter this? Well, as a defender, it's probably a good idea to look through your systemd services and see what services you have running on your machine, right? That would be probably a good thing to know. So how do you do that? Well, there are two good ways of listing the services on your machine. If I do it with sudo, I actually don't think I need sudo for this, but I'm running it just in case. If I do system control, I can either say list units or I can say list unit files. And both of those are going to display the services that are on my machine, but they're going to give me some different information. So list units is useful because it tells me what services are running or aren't running. So I can use my arrow keys to navigate this a little bit more. But you'll notice this in these tabs here, you can actually see, if I go down here, which services are running versus which services exited, right? So that's pretty useful. And then the other one, list unit files. This one lets me see which services are enabled or disabled. So when we're talking about a service being enabled or disabled, we're talking about the state here, and that just means whether it's going to run on boot or not. So two things that it would be great to look through is one, what services are actually running on your machine? So I can say system control list units, and we can grep for running. And this is just going to print out all the services that are currently running. And if we do this, and just to make it a little prettier, I'm going to pipe that output into more so I can read it. Right here at the top, we see this backdoor.service. Well, that's potentially interesting. Might want to look into that one. The other thing that we could do is we could list unit files and grep for enabled. So we can see all of the services that are going to start on boot. Again, if we go through this list of enabled services, we see down here, backdoor.service is also enabled. So that means it's going to start on boot. So again, probably worth investigating. So if let's say I want to investigate this backdoor.service, how do I find the full path to that service file? Well, I can always say system control status backdoor, and it tells me that the full path to that file here, if we take a look there, is etc systemd system backdoor.service. It says it right there. So I'm going to quit out of this, and I'm going to take a look at it. I'm going to say sudo cat etc systemd system backdoor.service. Now that we're looking at this backdoor, this looks kind of suspicious. It's a very bare bones minimum service. It doesn't seem to be doing much other than starting this file here, which is definitely not a file that comes by default in Linux. So that's a pretty good indicator that this is something malicious, especially since it's called backdoor. That is a pretty dead giveaway. But let's say you weren't sure. If you weren't sure, you could just keep that service file, but maybe name it something else. So maybe name it backdoor.back, for example. And then if you notice that getting rid of it breaks something, or stopping and disabling that service breaks something, you can always get it back up and running. I'm going to show that in a second. The first thing I want to do is I want to actually stop that service from running. So I'm going to say sudo system control stop backdoor. You can just use the name of that file without the .service extension. Second thing I'm going to do is I'm going to disable it so it does not run on boot. Just like that. And now we've stopped that backdoor service and we stopped it from running on boot. At this point, I would take a step back. I would make sure that everything on your machine is still working. I would make sure that you're still being scored by the scoring server and that no legitimate services went down. So I'm going to do a really quick ss-plunt. I'm going to search for the service that I want to actually have running. So let's say in this case, this is a web server. So I want to make sure port 80 is still up. It looks like port 80 is in fact still up if we look over here. So I'm pretty confident that that service was not necessary and that it was malicious. Okay, in this case, I have two options. The safer option that I highly recommend is just to say sudo mv, and I'm going to take that systemd file that I found before, that service file, backdoor.service, and I'm just going to rename it to something else. So I'm going to name it something that doesn't end in .service. So I'm going to say backdoor.back for backup. This way, if I ever figure out that that service, I actually do need it, I can always switch it back, by renaming the file back to backdoor.service and then starting it and enabling it, right? So I would do system control start, system control enable. Pretty self-explanatory at this point, hopefully. And then if I know for sure that this is a malicious service and I actually don't want it, then I'm going to do sudo rm etc systemd system backdoor.back. I can remove it completely, right? Before I do that, I actually want to remove the file that service is running, because if that service is malicious, then it's quite probable then that the file that it's running is also malicious. So if I print out the contents of that service again, you'll notice that the file it ran was /bin/payload. So what can I do with that information? Well, I'm going to take a look at /bin/payload. This probably looks malicious to me, but let's say I'm not entirely sure. We can do what we did in a previous video, where we actually just make this file not executable. So we can change the permissions on this file, chmod 000/bin/payload. And now nobody's going to be able to run that file anymore. But in the event that it turns out we actually do need it, we can always set the permissions back to what they were before. So we can say chmod 755. We can restore the service and get it back up and running. But if we're pretty sure that this is, if we're like 100% sure that this is malicious and we do want to remove it, then we can remove it. Again, I caution against removing anything because what if it turns out it was legitimate and you did need it? In that case, you always want to have a way of restoring it in the event that you do need it. And so that's why I recommend setting the permissions as such so that you can't actually run that executable, or maybe just renaming that backdoor.service to something else so that systemd doesn't recognize it. And then you can always restore it if you need to restore it. Again, since we modified a systemd service file, whenever you modify a systemd service file, you have to reload the systemd daemon. So we're also going to run sudo systemctl daemon reload. If you don't actually reload that daemon, then that service is still going to exist and it's still going to work. So very important, after you either change the name of or remove that service file, be sure to reload the systemd daemon. At this point, the attacker's persistence is gone. If I go back to my Kali machine here and take a look at my beacons, how are they doing? You'll see that I lost all of my beacons at this point. Or I lost all of my connections. Whenever I say beacon, just think connection. Beacon just means a connection that undergoes that command and control process, that back and forth that we talked about in the first video. Point is, I lost all my connections, and so we know that I, as the attacker, was kicked out. And if we were to reboot the target machine, it doesn't make a difference. That service doesn't exist. I'm not going to get a connection back.